Welcome to the Introduction to CAD and CAE. In Simulation Thermal Part 2, you review whether a heatsink reduces the temperature from a heat source to an acceptable level. After completing this lesson, you'll be able to create a thermal simulation for a heatsink, apply materials to each body in the heatsink, apply thermal loads, perform a simulation based on the settings, then review the results and create a report. I've opened this applied file, thermal_heatsink, and we can see there are two bodies, lower and upper. Let's go from Model to Simulation. The new study is going to be Thermal, and click OK. First thing I'm going to do is change the material. They're both set to steel in the model, and for the lower part, which is applying the heat, we'll leave that as steel. But we're going to change the upper part, the part that's dissipating the heat, and change that to aluminum 6061. Go to Bodies, hide the upper body, then go to Load. So on thermal loads, it's going to be an applied temperature. Select that face, and change the value to 100. Show the upper body, again back to Load, but in this case change the type to Convection. Select all faces, select the part, and we can see there are 213 faces have been selected. For convection value, you can change the units. There are a number of selections here, there are 5 of them. Our default is acceptable, and the value that I've been given is 240. But that's not meters squared, that's centimeters squared, so I'm changing that. And the ambient temperature, changing that from 20 to 28. Click on OK. Then go to Contact, Automatic Contacts, and Generate. There are only the two bodies, and they are connected together, so that 0.1 millimeter gap was acceptable. I'm now going to generate a mesh. And once that mesh is generated, I'll review it to see if it's a suitable size. Let's zoom in on that. That top area is fairly thin, but I think that's going to be acceptable. We can always make that smaller in the future if we want. Go to the pre-check. We have all the information. Then go to Solve. On the cloud, or locally, in this case, locally. Click Solve. And we see that under Job Status, it has started. The results have been completed. The solve is successful. And we see the range of temperatures from min to max. And they're also highlighted on the screen with probes. The minimum value is just off to the side. That's probably due to the mass of the material in that area. Let's check that out by creating a slice plane under Inspect. And I want this plane to go through one of those long fins on the heatsink. Go to the front view, and now we can see how that heat was dissipated throughout the heatsink. Using a probe, we can run that probe over that fin, and see the temperature dissipates pretty quickly through the top there. We may want to reconsider that design. We can probably make it smaller. Click on OK. Back to the home view. And just undo that to get rid of the plane. The next thing I want to do then is look at the right view and consider what options I have. I think it's possible to reduce the height. We may also want to consider putting a taper on here. These are vertical, and perhaps a small fillet at the bottom, increasing the surface area, but keeping in mind we need to keep that air gap in there to allow the heat to dissipate. We can now go to Results, create a report, and share that report with other members of the design team. From Simulation, let's go back to Model. Under Model, we can start a live review session, and we have 3 options that we can share.